Okay, move out.
Since that fateful day over Hiroshima 20 years ago, we have come to think of weapons development as a revolutionary process. However, many weapons are the direct descendants of earlier versions first developed generations ago. The Minutemen of Lexington and Concord used a gun which was the forefather of the M14 rifle. Even the giant rockets of today's space program are descended from Dr. Robert Goddard's far-sighted experiments in the early 1930s. The tank was also once the crude expression of a primitive idea. But it too has evolved into a more familiar and vital weapon. Although the concept of the tank was first conceived by Leonardo da Vinci many centuries ago, it is from the First World War that we can trace the origins of the modern tank. After the initial German advances into France, the great armies of Europe faced each other across the long, static lines of the Western Front. After 3 years, millions of men had died in the continual effort to break through. The strategists reasoned that if only sufficient numbers of men moved to the front and charged once more against the machine guns and barbed wire, they were bound to get through. But again and again they failed. The stalemate continued. For many months, a few innovators in the British Army had been working on a solution: a mobile armored vehicle which could carry enough firepower to destroy machine gun emplacements as it led the troops through the lines. Finally, in September 1916, the British launched the first mass attack with the new weapon. They were called tanks, a term Army intelligence hoped would deceive the Germans into thinking these new machines carried only water for the troops. The engagement was a brilliant success. In a war that had dug in, settled down, and taken cover behind hundreds of miles of trenches, the tank, however primitive, could actually break through, opening the way for the infantry. While England continued to develop more efficient models, the French and Germans were soon producing their versions. The Italians were quick to pursue their own tank program, which included some rather vigorous field tests. Perhaps they expected too much. The final year of the war proved the enormous value of infantry and armored cooperation. The tank had brought back movement and mobility, once denied by trench warfare, and it reinstated this movement with a merciful cut in casualties. In 1916, during the first few hours of the Battle of Somme, the British lost 60,000 men, while advancing only a few thousand yards. While at Cambrai, with strong tank support, only 9,500 men were lost during an advance of 10,000 yards. It was a new era of warfare, although it still remained for Hitler, 20 years later, to convince all those who still swore by the cavalry. The tank had been designed to break the stalemate, but when it helped force the Germans into full flight during the last weeks of 1918, it was obvious that this tough but sluggish vehicle would have to be reconsidered and improved in future years. During the 20s and 30s, the major powers continued to develop the new weapon. At Aberdeen Proving Grounds in Maryland, new designs, ideas, and better equipment were worked on. The hull was modified, and various solutions to the difficult problem of suspension were sought. As the Allies worked under the limitations of a peacetime budget, the German army secretly prepared for war. Colonel Guderian conceived the true role of the tank in the modern army. His idea was to force a lightning decision by committing masses of tanks in combination with motorized infantry, artillery, and aircraft. This was the revolutionary tank school of warfare. When the war finally arrived, theories suddenly became realities. Poland was overwhelmed by the speed and striking power of a modern mechanized army timed for a war of movement, the Blitzkrieg. When the Panzer Division struck a few months later at the Low Countries in France, they swept the defending armies out of their way. In a few weeks, the Western Front had fallen. The world had changed greatly since the days when the great armies clashed in 1914. During the long years of the war, each nation worked to improve their tanks. The Russian T-34 carried a powerful weapon which inflicted heavy damage. The United States M3, General Grant, played a key role in the early years, but the side mount of the 75mm gun provided a limited field of fire. Newly developed British models proved to be the key to victory at El Alamein. The M4 General Sherman, the first medium-type tank to carry its main gun on top of the hull, possessed the mobility and firepower to break through defenses with swift and telling effectiveness. The trenches no longer sheltered regiments of huddling men. The infantry, artillery, and engineers had mobility and security of movement never known before. During the last years of World War II and in the late 40s and 50s, the United States developed several improved tank models. But the main emphasis of our defense policy was devoted to the perfection of nuclear weapons and the capability of delivering a fatal blow to any potential enemy. The armed forces developed increasingly sophisticated missiles, and the race for space committed the United States to a heavy program in this new technology. These developments supported the policy of massive retaliation, which President Eisenhower and his advisors believed would deter the Soviet Union from any act of full-scale aggression. However, the challenge of communist-inspired local conflicts, or wars of national liberation, required a more flexible response and conventional weapons. At the vast tank plant in Detroit, Michigan, plans were formulated to meet these new demands. A new tank, one of many, the M60, had to be developed and produced. Engineers from the Army began to work on the designs with specialists in research and development. After many months, they came up with the final blueprints. A prototype was built and sent to government proving grounds for testing and evaluation. First, the M60 and later the M60A1 proved that these models had achieved a high degree of protection, firepower, and mobility. It was simple to operate, durable, and reliable. It had to be all these things to meet the requirements as the Army's primary assault weapon. The firepower consisted of a 105mm cannon and 2 machine guns. All weapons can be fired from within. A computerized fire control system brings the full fury of the tank's guns on any target with telling speed and accuracy. For many months, the tank underwent a vast variety of tests. It churned through grinding sand, which would quickly have reduced a lesser vehicle to a pile of clanking rubble. The M60 is powered by a 750 horsepower air-cooled diesel engine, capable of moving the tank some 300 miles without refueling. Day after day, it thundered through muddy swamps and across washed-out gullies, always moving under perfect control, while the continual check on brakes, acceleration, and the control system went on. The vehicle can easily cross man-made obstacles. It can climb vertical walls as high as 3 feet. It remains completely leak-proof as it travels through 4 feet of water. At the conclusion of the test, it was judged that the new tank had met all the requirements to become the Army's main battle tank. It was ready for production. Center of production for this mammoth job is the government-owned Detroit Tank Plant, which is operated by the Chrysler Corporation and supervised by the project manager, M60 Tank, for the United States Army. Organization is on a vast scale. More than 500 separate companies in 25 states and Canada supply the equipment for the tank, which is assembled at the plant. This scene is repeated many times as separate groups of engineers develop every detail of each component. Product improvement never stops, even though tanks are rolling off the assembly line. It takes a whole department merely to keep track of the constant engineering refinements, notify the right people of the change, and make sure it appears on every tank built after a certain day and hour on the production line. It's a complicated proposition because a crucially important change in one part usually touches off a series of minor changes in related parts. The hull starts out as a cast steel shell, but shortly every inch of it will bristle with all kinds of complex and vital equipment. This particular hull is the master. It serves as a checkpoint for all others and as a pattern for the fixtures. The accuracy of each fixture must be constantly checked against the master hull. At one point, the welders work as a coordinated team on both inside and outside. The hull is placed in a cradle, which can rotate and hold it in any position to eliminate the hazards of overhead welding. Inspectors check the 500 weldments